Hello everyone. Today we are going to study about some basic concepts of chemistry. So let's study it in detail. Moving to our disclaimer slide, which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images promptly. So this is our index slide, and these are the major topics which we will going to study today. So first one, we will study about some basic definitions, then mole concept and molar mass, physical quantity and their measurements, some significant figure, dimensional analysis, various concentration terms, chemical equation and stoichiometry, limiting reagent, Dalton's atomic theory, laws of chemical combinations, and lastly, equivalent weight. So, definition: chemistry is the branch of science which deals with the composition, properties, and interaction of all kinds of matter, such as air, water, rocks, plants, earth, etc. So, chemistry is a branch of science which deals all these phenomena which we see in our nature, in our surrounding, in our day-to-day life. So, matter and its nature. Anything that occupies space and possesses mass is called matter. So, in our surrounding, everything almost is a matter because they occupy space and they possesses mass. On the basis of physical state of substance, matter is divided into three types: solids, liquids, and gases. So, solids have definite volume and definite shape. It is a property, physical property of solids, that it has a definite volume and a definite shape. Liquid have definite volume but not the definite shape, and gases have neither definite volume nor definite shape. So, on the basis of chemical composition of the substance, it is of three types: elements, compounds, and mixtures. Elements are the substances that cannot be decomposed into simpler substances by chemical change. So, elements, we can say that if we look upon a chemical composition of any substance, element are the smallest part, and element cannot be decomposed into simpler substances by any chemical change. Compounds are compounds can be decomposed into simpler substances by chemical changes, so it can be decomposed. Okay, compound is always homogeneous. Third one is mixtures. These have variable composition. They have variable composition and variable properties due to the fact that components retain their characteristic properties. Okay, components of a mixture can be separated by applying physical methods. If we want to separate the components in the mixture, we can do it, but by applying physical methods. Every substance has unique property, and these can be measured qualitatively and quantitatively. We are talking about the property which every substance has, and we can measure that either qualitatively or quantitatively. Moving to the next slide, which is mole concept and molar mass. So, mole is the amount of substance which contains 6.022 into 10 to the power 23 particles, and this number is also known as Avogadro's number, and it has a mass equal to gram atomic mass or gram molecular mass. So, mole is a unit, basically measuring unit, or it is the amount of a substance which contain this number of, or Avogadro's number, particles, these many particles in it, and has mass. Every particle has mass, so has mass equal to gram atomic mass or gram molecular mass. So, mole is related to mass of a substance in grams, volume of a gaseous substance, and number of particles. So, mole is related to all these three concepts, and basis on this definition, we can define the number of moles as mass of substance in gram upon molar mass in gram mole inverse, volume of gas at standard temperature and pressure, that is 0 degrees Celsius and 1 atmospheric pressure, in liter, divided by 22.4 liter mole inverse. This is a constant. This is actually at this is defined as like that at standard temperature and pressure, 1 mole of an ideal gas occupies 22.4 liter volume. So this is that value. And number of moles can also be equal to number of particles at standard temperature and pressure divided by the Avogadro's number. That is this number, 6.022 into 10 to the power 23. Moles of atoms, molecules, or ions multiplied by Avogadro's number. This is Avogadro number, is equal to number of atoms, molecules, ions, or electrons. Basically, if we want to find out the number of particles present in any atom, molecule, or ion, will be equal to mole of that atom, molecule, or ion multiplied by Avogadro's number. This will count the total number of particles present in that particular atom, molecule, or ion. Okay. Second important thing, total charge present on an ion. If we want to find out, that can be written in the term of number of moles. That is number of moles multiplied by Avogadro's number multiplied by charge on one ion and multiplied by 1.6 into 10 to the power minus 19 coulomb, which is the charge of an electron in an atom. Okay, so this is the way by which we can find out the total charge present on an ion. Molar mass of an element is defined as mass of 1 mole of a substance in grams, that is mass of 6.022 into 10 to the power 23 entities or particles of that element. So these are some molar concepts and mole concepts related to the mole which we have studied in this slide. Moving on, percentage composition, empirical and molecular formula. So the percentage of any element or constituent in a compound is the mass of the element or constituent divided by the total mass of the compound. Okay, so if we want to find out the mass percent or percentage composition of any element in a compound, we can do this thing. Okay, like we have to calculate the mass of element in the compound, multiply by 100 for the percentage, and divided by the molar mass of that whole compound. Okay, so through this we can find out the mass percentage of an element in a compound. Empirical formula. Empirical formula represents the simplest whole number ratio of various atoms present in a molecule of the compound. Okay, so in a compound or in a molecule of a compound, the various number of atoms present in a whole number ratio, this will be represented by empirical formula. Whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. Whereas if we look upon the molecular formula, it shows us the exact number of different type of atoms present in a molecule of a compound. So N will be the number of moles will be equal to molecular mass divided by empirical formula mass. N is not number of moles. Basically here N is the factor by which you multiply the empirical formula to obtain the molecular mass. Okay, and N is any integer such as 1, 2, 3, etc. And we can also write this formula in this way, that is molecular formula will be equal to N multiplied by empirical formula. Okay, so N is a factor by which we multiply the empirical formula to obtain the molecular formula. Okay, and molecular or molar mass will be equal to 2 cross vapor density. So basically vapor density is a comparative measure of gas density, any gas density relative to the hydrogen. Okay, so that is vapor density. So we can also find out the molecular mass by this formula and using the N by the empirical formula. Moving on to next slide, that is physical quantities and their measurement. Mass, length, time, and temperature are physical quantities. These are expressed in numerals with suitable units. They have suitable units of theirs. Units may be basic or fundamental or derived. We can derive it from the fundamental units. The SI system has 7 base units. These units pertain to the 7 fundamental scientific quantities. And what are these? The unit of mass will be kilogram, length, meter, time, second, electric current, ampere, temperature, Kelvin, luminous intensity, Kelvin, and amount of substance, mole. These are the fundamental units of these fundamental physical quantities. Okay. The lowest temperature permitted in nature is minus 273.15 degrees Celsius, which is basically 0 Kelvin. Okay, Kelvin and Celsius are the units of temperature. This temperature is known as absolute zero. So minus 273.15 degrees Celsius temperature is known as absolute zero. Relationship between Celsius and Kelvin scale is given by this expression, that is Kelvin will be equal to degree Celsius plus 273.15 degrees Celsius. If we have a temperature in degree Celsius, we have to add it in 273.15 and we can get our Kelvin temperature by this. So, relationship between the Celsius and Fahrenheit scales are related as degree Celsius will be equal to 5/9 multiplied by degree Fahrenheit minus 32. Okay, so this is the relationship between the Celsius and Fahrenheit scales. This will be the temperature of degree Celsius. This will be the temperature of degree Fahrenheit. A number of quantities must be derived from the measured value of the SI-based quantities. Okay, so some number of quantities have to be derived from measured value of the SI-based quantities, and these are called the derived units. So basically, we can derive some units from the simple or fundamental units, and these are known as derived units. For example, unit of density. So density formula is mass upon volume. So density unit will be derived from the unit of mass and unit of volume. So kilogram per cubic meter, okay, is derived from the unit of mass, which is kg, and volume, that is cubic meter. There is a note here that the term precision refers for the closeness of the set of values obtained from identical measurements of a quantity. Precision is simply a measure of reproducibility of an experiment, while accuracy, a related term, refers to the closeness of a single measurement to its true value. So the closeness between closeness of a single measurement to the true value is known as accuracy, and precision is different from this. So this is a note points. Okay, moving on to our next slide, that is significant figures. So significant figures are meaningful digits which are known with certainty. These are the total number of digits in a number, including last digit, whose value is uncertain. The uncertainty is indicated by writing the certain digits and the last uncertain digit. So, certain rules for determining the number of significant figures are as follows. So, first one, read the number. If we have a number, we have to read the number from left to right and count all the digits present in it, starting with the first digit, that is non-zero. So if we are having a number, we have to start counting the digits from left to right, and the first digit should be non-zero. In addition or subtraction, the number of decimal places in the answer should not exceed the number of decimal places in either of the numbers which we are adding or subtracting. While in multiplication and division, the result should be reported to the same number of significant figure as that in the quantity with least number of significant figure which we are multiplicating and divising. Okay. When a number is rounded off, the number of significant figure is reduced. The last digit retained is increased by 1 only if the following digit is greater than 5. And the last digit will left as such if the following digit is less than 4 or equal to 4. Okay, so these are some rules we can use or we have to put in our mind when we are determining the number of significant figures. Okay. Moving on to the dimensional analysis. In calculation, many of the times it becomes necessary to convert units from one system to another. This is achieved by factor label method, unit factor method, or dimensional analysis. The dimensions of a derived quantity are the powers to which the basic quantity have to be raised in a product defining the quantity. Dimensional analysis involves calculations based on the fact that if two quantities have to be equated, they must have same dimensions or same units. Okay, if we are equating two quantities, they have to be the same dimensions or same in units. Okay, moving on. So these are we will study now about some various concentration terms. So different concentration terms are given below. First one is molarity, represented by capital M. It is defined as the number of moles of solute per liter of solution. Number of moles of solute per liter of solution, or as number of milligram molecules per milliliter of solution. So units will be changed in both, like numerator and denominator. The molarity is usually designated by capital M. It is dependent upon the temperature, as it depends on the volume and which changes with the temperature. So basically molarity is depend on temperature, because in the formula of the molarity, volume will come and volume changes with the temperature. So molarity will directly related with the temperature. For example, if the molarity of H3PO4 is 0.18, it means a concentration corresponding to 0.18 mole of H3PO4 per liter of solution. Okay, so if we are talking about concentration anywhere, that means we are talking about the molarity of the solution or the whatever compound. Okay, so the molarity is given as moles of solute upon volume of solution in liter. Okay, if specific gravity is given, then the formula will change to specific gravity multiplied by the percentage strength multiplied by the 10 divided by the molecular weight. Okay, now if molarity and volume of a solution are changed from some initial value m1v1 to m2v2, then m1v1 will be equal to m2v2. This is known as molarity equation. Okay, this is a point to be noted. If two solutions of the same solute are mixed, the molarity of resulting solution will be this. Solute are same and two solutions are mixing in which solutes are same. So the molarity of resulting solution will be defined as M3 will be equal to M1V1 plus M2V2 divided by the sum of the volume of two solutions. Okay. Strength of solution denoted by capital S. Amount of solute present in 1 liter of solution. So what amount of solute present in the liter per liter of solution will be the strength of the solution. The formula is weight of solute upon volume of solution in liter. Molality. Molality is represented by a small m. It is defined as number of moles of solute dissolved in 1000 gram or 1 kg of the solvent. Okay. It is designated by small m. Molality is independent of temperature. Okay. It is independent of temperature, as it depends upon only on the mass, which does not vary with the temperature, because mass is a constant quantity. It does not depend on the temperature. That's why molality will not depend on the temperature. So molality formula will be moles of solute upon weight of solvent in gram multiplied by 1000. Okay. Next one, normality. Capital N will be the denoting sign of this. It is defined as number of gram equivalent of solute per liter of solution, or number of milligram equivalents of substance per milliliter of solutions. Units will be changed in both numerator and denominator. For example, 0.12 normality of H2SO4 means a solution which contains 0.12 gram equivalent of H2SO4 per liter of solution. Okay, this also means that each milliliter of the solution can react, for example, with 0.12 milligram equivalent of calcium oxide or with 0.12 milligram of Na2CO3. Okay, so thus normality will be equal to gram equivalent of solute divided by volume of solution in liter, or gram equivalent of solute divided by volume of solution in milliliter multiplied by 1000. Okay, moving on. If a specific gravity is given, then the normality is calculated as formula will be changed, that specific gravity multiplied by percentage strength multiplied by 10 divided by equivalent weight. This will be the formula of normality if the specific gravity is given. If normality and volume of solution are changed from N1V1 to N2V2, then N1V1 will be equal to N2V2. If two solutions of same solute are mixed, then normality or resulting solution will be N3 will be equal to N1V1 plus N2V2 divided by the sum of volume of both the solutions. Okay. Next term is mole fraction represented by X. It is the ratio of number of moles of a particular component to the total number of moles of a solution. Okay. Moles of particular component divided by the total moles present in the solution. Thus, mole fraction formula will be number of moles of component upon number of moles of solution. And the sum of mole fractions of the component in a solution is equal to 1. This is a point to be noted. Okay. Moving on. Chemical equations and stoichiometry. A balanced chemical equation with suitable stoichiometric coefficients represent the ratio of number of moles of reactants and products. A chemical equation provides qualitative and quantitative information about a chemical change in a simple manner. Stoichiometry deals with calculation of masses of reactants and products involved in a chemical reaction. Okay. The numerals used to balance a chemical equation is called stoichiometric coefficients, which we represent by numerals and which we place in front of or in the starting of a chemical formula in a chemical reaction. Okay. For this stoichiometric calculations, the mole relationship between different reactants and products are required. The mass volume, and volume volume relationship can be obtained between different reactants and products. Okay. Moving on to limiting reagent. So, a substance which is completely consumed in a reaction is called limiting reagent. It determines the amount of product that will be formed in a chemical reaction. Okay, so a reaction yield will be equal to actual yield multiplied by 100 divided by theoretical yield. Okay, actual yield means after the experiment what we get, and theoretical yield means after the calculations from the formula or a chemical formula what we get. Okay, that is theoretical yield. In stoichiometry, if the quantities of two or more reactants are given, the amount of products formed depend upon the limiting reagent or the reactant which consume first in the reaction, which is limiting reagent, right? So this is the point to be noted. Moving on to Dalton's atomic theory. So John Dalton developed his famous theory of atoms in 1808. The main postulates of this theory were: first one, atom was considered as hard, dense, and smallest indivisible particle of a matter. Atom is indestructible, that is, it cannot be destroyed or created in a chemical reaction. Atom is the smallest portion of matter which takes part in chemical combination. Atoms combine with each other to form compound or molecules in simple whole number ratio. Atoms of same elements are identical in mass and chemical properties. So if we are talking about the elements, so if we are taking the atom of same element, that means in an element many atoms are present, right, of that element. So if we take any two atoms of that element, same element, that means those two atoms have identical mass and same chemical properties. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. This is mentioned here also. Okay, so these are the points or postulates which Dalton atomic theory explained or given by the John Dalton. Moving on to laws of chemical combinations. The combination of elements to form compounds is governed by the following basic laws. First, law of conservation of mass, given by Lavoisier in 1789. Total mass of reactant will be equal to total mass of the product in a chemical reaction. That is known as law of conservation of mass. Second law, law of constant composition or definite proportion. So Prost, given by Prost in 1799. For the same compound obtained by different methods, the percentage of each element should be same in each case. Okay, this is given by the Prost, and this is law of constant composition or definite proportions. Third one is law of multiple proportions, given by Dalton in 1803. An element may form more than one compound with another element. For a given mass of an element, the masses of other elements are in the ratio of small whole numbers. For example, in NH3 and N2H4, fixed mass of nitrogen requires hydrogen in the ratio 3:2. Okay, so this is the law of multiple proportions. Law of equivalent or reciprocal proportions, given by Richter in 1794, explain as when two different elements combines with a fixed weight of a third element, the ratio of their combination will either be same or multiple of the ratio in which they combine with each other. Okay, so this is the law of equivalent or reciprocal proportions. For example, CH4, CO2 and H2. Fifth law, law of combining volumes, given by Gay-Lussac in 1808. It states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. So this is the law of combining volumes. Avogadro's law, which is the most famous law, it states that equal volume of all gases at same temperature and pressure should contain equal number of molecules. Okay, so these are the 6 laws which we have talked about in this slide. Moving on. Atomic, molecular and formula masses. Atomic mass. It is defined as number which indicates how many times the mass of one atom of the element is heavier as compared to 1/12th part of the mass of one atom of carbon-12. Okay. Second, gram atomic mass. The gram atomic mass of an element should not be the mass of the atoms. Okay, so these two should have to be different. For example, gram atomic mass of hydrogen element is 1.008 gram, but mass or atomic mass of hydrogen atom is 1 unit. That is 1.67 into 10 to the power minus 24 gram. Okay. The approximate atomic mass of solid elements, except beryllium, boron, carbon, and silicon, is related to specific heat. That is, average atomic mass will be equal to 6.4 divided by specific heat. And this is given by Dulong and Petit's law for metals. So, exact atomic mass will be equal to equivalent mass multiplied by valency. As most of the elements have isotopes, so their actual atomic mass is the average of atomic masses of all the isotopes. Average atomic mass is calculated as this formula. By this formula, using this formula, that is M1R1 plus M2R2 plus M3R3 upon R1 plus R2 plus R3, where R1, R2 and R3 are relative abundances of the isotopes. Okay, so this is the thing. Basically, isotopes are the elements which have same atomic number but different atomic masses. Okay, so we if we want to find out the average mass, we have to find out by using this formula for particular element. Moving on to molecular mass. It is the sum of atomic masses of an element present in a molecule. It is obtained by multiplying the atomic masses of each element by the number of its atoms and adding them together. So this is the way by which we can find out the molecular mass of a element or a compound. Formula mass. It is sum of atomic masses of all the atoms in a formula unit of the compound. It is normally calculated for ionic compounds. This is a point to be note. So formula mass of NaCl will be given as 23 plus 35.5 equal to 58.5 atomic mass unit or 58.5 unit. Okay. So NaCl is an ionic compound and we can find out the formula mass of NaCl like this. Moving on to the equivalent weight. So it is the weight of an element or of a compound which would combine with or displace 1 part of hydrogen or 8 part of oxygen or 35.5 part of chlorine. Okay. Basically, equivalent weight will be equal to atomic weight or molecular weight divided by the N factor. What is N factor? So N factor for various compound can be obtained as first N factor for acids, that is basicity. is the number of ionizable H positive per molecule. For example, for HCl, the basicity of HCl will be 1. So N factor will be 1. N factor for bases, that is acidity. That is the number of ionizable OH negative per molecule. For example, acidity of NaOH will be 1, N factor is 1. N factor for any salt is total positive or negative charge of ions. Like in ionic compound Na2CO3, which dissociate as 2Na positive plus CO3 2 negative. So positive and negative charge sum will be the N factor for the salt Na2CO3. N factor for an ion. So if you want to find out the N factor for ion, that is equal to the charge of that ion. Okay, so like for Cl minus, the charge will be -1. So N factor will be 1. Okay, in a positive way because N is a integer. In redox titration, N factor for reducing agent is number of electron lost by the molecule. And for oxidizing agent is number of electron gained by the molecule. Okay, so for example, FeSO4. So as reducing agent, Fe2 positive will give Fe3 positive an electron. The N factor will be 1 here. Because number of electron losing is 1, so N factor will be 1. And if we see it as an oxidizing agent, then Fe2 positive plus 2 electron, that is Fe. So N factor will be 2 because 2 electron are gained by Fe, okay, Fe ion. So equivalent mass of oxidizing or reducing agent will be equal to molecular mass of oxidizing or reducing agent divided by the number of electrons gained or lost by the one molecule. Thank you.